Okay, this video is going to talk about how to simplify a radical expression. So just in case you don't remember what that is, that's something like, let's say, I don't know, 72 x cubed y square root. Okay, so this square root, this is your radical. Okay, this is the radical. And this inside is the expression. Okay, so I'm going to show you how to simplify this without using the calculator. Okay, so let me go ahead and erase this for now because that's a little too difficult for us just now. We're going to start with something pretty simple. Okay, I went ahead and wrote down the steps for this. You should probably write this down in your notes. There are 3 steps. The first one is to rewrite the number in terms of your prime numbers. So like 3, 5, 7, 11, 2, even though 2 is not a prime, but still 2, and so forth. Then we circle all the pairs because we're dealing with the square root of x. Just a quick reminder, you might want to write this part down, but hang on. But the square root of x, remember this is the same as x to the 1/2, okay? Which is also the same as taking the root of 2 from something, but we never write that 2. It's kind of like an imaginary 2 in front of the square root in that little space right here, okay? Anyway, and then finally pull one of the numbers from each pair to the outside. Okay, so this is best shown with examples. Okay, so let's say we have the square root of 12, something pretty simple. Okay, I'm going to rewrite 12 in terms of its primes. So when I do that, I start factoring. So I know that 12 is 6 times 2, and I know that 6 is 2 times 3, and I'm just going to bring that 2 down. Okay, so these are the prime numbers. So in this case, I have a pair of 2's, so I'm going to circle them. I have 2 2's right here. And since we're talking about the square root, that means that we're actually looking for like a pair. So anywhere I have a pair, I'm going to pull one out from them. So let me kind of rewrite this just so you can see. This is 2 times 2 times 3. I'm just changing the order here. Okay, which is the same as this 12. So if I were to multiply 2 times 2 times 3, I would get 12. Okay, so my steps say I'm going to circle all the pairs. So I'm going to circle these 2's. Okay, and then it says pull one number from each pair. So I'm going to pull out one of these 2's to the front, and that kind of gets rid of both of them. Okay, I know it doesn't make too much sense, but it will in a little bit. Okay, and whatever's left inside just stays inside. So this is 2 times the square root of 3. And if I were to multiply this, I would get the square root of 12. Okay, so this is what I'm looking for, this answer. If you were to put this 2 back inside, it would be like saying 2 times 2. Okay, let's go ahead and try another one, just so we can get practice. Let's say we have the square root of 36. Okay, this one should be pretty simple because you should know that 36 is the same as 6 times 6. Okay, and in this case, because we already have a pair here, okay, I can already circle them. So I'm going to pull out one of these 6's out, which is 6 square root. Well, I didn't leave anything inside, so there's an imaginary 1. But we know what the square root of 1 is. The square root of 1 is just 1. So this one is just 6. Okay? And that's why this works. Right? Let's try another one. Something a little more complicated. Let's say we have the square root of 48. Okay, so the square root of 48, I know that 48 is 6 times 8. And there's no pairs, so I have to keep going. This is 2 times 3. And this one is 4 times 2. And I have one pair, I have a pair right here, okay, but I'm going to keep going because maybe I'll have one more, okay? And then 4 is 2 times 2. Okay, so I'm going to bring everything down. And I'm going to circle all my pairs. So if you have a pair in the beginning, like we had the pair here, okay, but you still have some numbers left over, you want to keep going further to the primes because look what happened here. Okay, we have another pair here. So I'm going to go ahead and circle all my pairs. I have a pair here, and I have a pair right here. So I have 2 pairs of 2s. So this is going to be, let's say I can take this 2 out from the front right there, and this 2 out from here, and that's it. So remember, you take out one number from each thing that you circled with the square root of 3. And because I pulled out more than one number in this case, I have to multiply them. So 2 times 2 is 4, and then I have the square root of 3. Okay. And if you wanted to kind of check this, you could actually take this 4 and plug it back in. Okay, remember when you plug it in, it's like it gets doubled. Okay, so it would be like saying 4 times 4 times 3. You don't have to write this, it's just kind of extra. 4 times 4 is 16, and 16 times 3 is 48. Okay, so this works out as well. Okay, go ahead and do one more number example, numerical example, and then we're going to start adding some letters in here. Okay, because what's math without complications, right? Okay, so let's say we have the square root of, I don't know, let's say 200. Let's make it interesting. Okay. Well, I know that 200 is 20 times 10. Okay, and I know there's other multiples, but I'm using the ones that I don't think I have to break down too much. Okay, so from here, 10 is 2 times 5, and that's all I can do with those. I can't really break those down anymore. And 20 is 4 times 5. So I already see that I have a pair here, 5 and 5, but I know that 4 can be broken down some more, so I'm going to go ahead and break that down as well. That's 2 times 2. Bring down the 5, bring down the 2, bring down the 5, and now these are all my prime numbers, okay? So I'm going to go ahead and circle all my pairs. I have a pair right here, and I have a pair here, the 2 5s. Okay, so this is going to be equal to, I'm going to take 1, 2 out, one of the 5s out, and I'm left with that 2 on the inside. So this is going to be equal to 2 times 5 is 10, square root of 2. Let's see if this is correct. Remember, if we were to plug this 10 back inside, it gets doubled. So that would be like saying 10 times 10, and then times that 2. 10 times 10 is 100, times 2, which is 200. Okay. And of course, some of you will get the hang of this very quickly, and you're going to notice that if you can find like a perfect square, like 100, okay, it makes it way easier. Okay. So I'm going to do some more examples with letters now. So let's say we have the square root of, we'll say, x to the 5th power. Okay. For this one, I'm going to go ahead and draw the picture just so you can see. This is x times x times x times x, 1, 2, 3, 4, times one more. Okay, so I have 5 x's, and in this picture I can circle, let's see, 1 pair, 2 pairs, and that's it. So since I only circled 2 pairs, I'm only going to pull out 2 x's. So I have x times x. So this x is this one is the second one, square root of the one that's left over. And of course, x times x is just x squared. So this is what I end up with. Okay, so let me kind of go back through that because I did it kind of quickly. If you have a variable, okay, with an exponent, we can expand those letters. So this case I have 5, so I drew 5 x's, and in these 5 x's I circled a pair of 2 here and a pair of 2 here. Remember, the rule is to take out one number, or in this case, letter, from each pair. So I took out this x right here, which kind of got rid of both of them. And I took out an x from here, which again got rid of both of them. And so now I have one final x left inside, and that one stays inside. Whatever you pull out, you multiply. So x times x is x squared, and I just rewrite everything else. Okay, let's try another one. So you have the square root of y to the 11th power, and then we'll say x cubed. Okay, so this one has two letters. So just like the previous one, I'm going to expand it. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 y's and then 3 x's. Okay. And I'm taking the square root of all this. So just like the previous example, I'm going to circle all my pairs. I have 1, 2, 3, 4, 5. So 5 pairs of y's. So I'm going to put y to the 5th, okay, because I took out 5 of them. So, you know, y times y times y times y times y, 1, 2, 3, 4, 5. There's 5, so it's y to the 5th. Okay, save me some work. And then I have one pair of x's, so times x. Okay, so I have 5 circles for the y's. There's that 5 right there. And I have 1 circle for the x. So I only have one x. And inside I'm left with this y, so y, and this x, x. And that's it. That's all I can do with this. Okay? This does tend to confuse some people because of, you're not too familiar with this. We haven't really done this very often. So, if you need more help, please just come by and I will show you. Okay? So notice that for this one, it gets kind of tiring having to draw all these letters and numbers. Okay? So another way to do this, okay, when you're dealing with exponents, since we're dealing with the square root of 2, okay, I know that 11 divided by 2 is equal to 5 with a remainder of 1. Yeah, because 5 times 2 is 10, and there's 1 left over. I also know that 3 divided by 2 is 1 with a remainder of 1. So in order to avoid having to draw all this nonsense up here, I can just do this. Okay? My 5, there it is. My 1, it's right here, but I don't have to write it because it's just a 1. Okay? And the ones that are left over, those are the ones that go inside. So let's try this again with another example and see if you can do it this way. Okay? So let's say we have the square root of a to the, we'll say, 17th, and b to the 15th, and c to the 3rd. So let's throw another one in there. Okay. Well, I know that 17 divided by 2 is going to give me, let's see, 8, remainder 1. Okay. So for the a, I'm going to have 8 of them on the outside. Okay. For b, I have 15. So this was a. For b, I have 15 divided by 2. 15 divided by 2 is 7, with a remainder of 1. So I'm going to have 7 b's. Okay. And finally, for my c, 3 divided by 2 is 1, remainder 1. So I only have 1 c, okay, on the outside. So all of these numbers here, okay, these are the outside ones, if you want to think of it like that. And then these ones over here, this is that's horrible. Oh, let me do that again. That looks horrible. This is what's left over. I'm just going to underline it. So this is what's left over. So I have one of each. So a to the first power, b to the first power, c to the first power are left inside. But of course, remember that we don't usually write the one, so my final answer would look like this. A to the 8th, b to the 7th, c, square root of a, b, c. And the reason we're dividing by 2 again is because this is the square root. And remember again, the square root of x is the same as taking the root of 2 out, which is why we circle all those pairs of 2. Okay? Let's try one more. This is kind of a lengthy video. Sorry about that. But we got to get it done. Okay, so let's try one more. Let's say we have the square root of 72, a to the 13th, and b to the 7th. And we'll put a c in there. Why not? Okay, so this one has a combination of everything we just went over. So we're going to go ahead and do the number first. So this 72, I know, is the same as 9 times 8, okay? And then 9 is 3 times 3. 8 is 2 times 4. I can keep going. This is 2 times 2. Bring down the 2, bring down my 3's. Okay, and in here I have a couple of pairs. I have a pair of 3's and I have a pair of 2's. So for sure on the outside, I'm going to put everything over here. I have a 3 and I have a 2. Okay, and I have a 2 on the inside. So I know that there's going to be a 2 on the inside. Let's go ahead and just put a box around that. So this is going to be inside. Okay. Then for my variables, I have for a, I have a 13. So 13 divided by 2 is going to be 6, remainder 1. So remember the top number is what we're dividing. This right here, this 6 right here is what goes outside. So I have a to the 6th power. Okay. For my b, I have 7 divided by 2. So 7 divided by 2 is going to be 3, remainder 1. So for b, I have b to the 3rd power. Okay. And finally, for c, I only have a 1. There's no pairs at all. 1 divided by 2, that's a fraction. That's just 1 divided by 2, so we can't do anything with this one. So this one's probably going to just stay inside. Okay. So here's what it will look like. We have that 2. We have 1a. We have 1b. And then the c, there was nothing to divide, so we still have the c. So my final answer will be 3 times 2 is 6, a to the 6th, b to the 3rd, square root of 2abc. Okay. And that's it. If you have any more questions, please come by. And this is kind of a new topic, so it's a lot to take in. So please come by if you have more questions. Thank you.